In this video, I'm just going to talk a bit about uh, how to use Google Sheets in order to do some calculations regarding Einstein solids. So to begin with, we have our data already laid out in columns. So the columns are n sub a, the number of particles in Einstein solid A, QA, the number of units of energy in Einstein solid A, the multiplicity of A, and then we have the same for Einstein solid B. So what you can see is that the number of units in Einstein solid A is 10, and the number of units in Einstein solid B is 10. So they have the same number of particles in the way that I've set this up right now. And here, what we've done is we have assigned a set number of units of energy to Einstein solid A. So if I look, I can have 0 through 10. So the setup that we have here is basically two Einstein solids that each have 10 oscillators in them, and that they share 10 units of combined energy. So when QA is 0, there's no energy in Einstein solid A, then QB is 10. Okay, and then I have actually assigned, so if I click on this, the box here for Q sub B, it says that it's 10, the number of units of total energy, minus cell B6. And if I look, cell B6 is right here. That is the number of units in QA. So all this is saying is that QB equals Q total, the total number of units of energy, which is 10, divided or minus the number of units that are in Einstein solid A. And then each of these has the same basic form, except that it now references, say this one references B7. So what I've actually done is I only wrote, so this is just a trick for Google Sheets, I only wrote the first equation here, and then I just clicked here and dragged down. And you can see that the things to the right here also changed when I removed these values, because these are also equations that depend on Q sub B. Okay, so now let's talk about how to calculate the multiplicity. So if we look at our equation here for the multiplicity, fact is the Google Sheets equation label for factorial, and it takes the factorial of whatever is inside of its parentheses. So here I have the factorial of A6, the number of oscillators in solid A, minus 1, so that's n minus 1 or Na minus 1, plus the number of units of energy in Einstein solid A, which in this case is 0. So I'm taking the factorial of 10, the value of A6, minus 1, so 9, plus the value of B6, the number of units of energy. And then I divide it by the factorial of the number of units of energy in A, QA, which is B6 here, and then the factorial of the total number of oscillators minus 1. So A6 minus 1. So notice the parentheses I put in the denominator. So there's a parenthesis here enclosing both of these factorial terms. So that is how I calculate the multiplicity of Einstein solid A. And again, I really only wrote this equation for the first line, and then I just clicked here and dragged. And notice that A6 goes to A7. So notice this is A6 referring to this cell. Now it's A7 referring to this cell. So as you drag down, it will automatically update to go to the next cell. This is also why I needed to put a 10 in every single row for NA, because whenever I drag down, it's always going to reference the appropriate cell in that row. So I can't just put 10 at the top somewhere and then drag down. I have to put 10 in every single cell here Perhaps there's a better way of doing this, but this is the way that I do it. Okay, we can do exactly the same thing for omega b. So I again have my factorial equation here, where now I'm referencing E6 and D6. So E6 being the number of units of energy and D6 being the number of oscillators. So now I have a value for the multiplicity of each of my oscillators, and then I can find omega total by simply multiplying this together. So I just take F6 and multiply it by C6. So F6 is the multiplicity of B, A6 is the multiplicity of, or sorry, C6 is the multiplicity of A. And again, I can write this value only for the top line, and then I can just click and drag to fill in all of the other rows. So what you are going to be doing is you are actually going to be changing the number of oscillators in each of them. So for example, you could change this to 15. So then it would be 15 oscillators in Einstein solid A. So this is a different system, obviously. And then I can click and drag and Einstein solid A now has 15 oscillators in it. Note that the multiplicities of A changed and that the total multiplicities changed when I did that. So that is something that you will be doing in the worksheet. Okay, the last thing that I want to talk about is making a plot. So what I'm going to do is I'm going to hit this button here for Insert Chart. I'm going to click on the chart type, and I'm going to go to Scatter Plot. For the x-axis, I want to put in the values of QA. So I just hit x-axis and I highlight that. And for the series, I want to use omega total. So I'm going to have to actually drag this over here for the series. Hit this little button here to select data range and drag that. Okay. And there is my scatter plot of the values. And now, so that I know what this chart is, I'm going to click the Customize button here. So you can click Chart Titles or Chart and Axis Titles here. So the title of my chart, I will just say Einstein Solid Multiplicity. And then I will put the values for the number of Einstein solids. So Na equals Nb equals 10. So the number of oscillators in each of my solids. And then I will also put Q as 10 as well. So now I am able to see exactly what this involves. I have two oscillators, each with 10 units of, or 10 oscillators, and I have a total of 10 units of energy. And then I can click on this line here. Horizontal axis title will be Q sub A, because that's what I chose as my horizontal axis. And my vertical axis will be total multiplicity. All right, so now I have my chart set up. I have it labeled so I know what I'm plotting. And you can see that the total multiplicity is maximized when my energy is evenly split between the two Einstein solids. What you're going to do is actually see if that is true, even if I change the number of oscillators in each of the solids, and see what happens when I change the number of units of energy as well.